Devlog number 5. Well, I guess I'll be walking on the weather. In this devlog, I'm going to talk about leaves, wind lines, lightnings, raindrops and snowflakes, water surface, snow, weather management. But first, some small updates I did since the last video. The birch trees were looking nice, but I wanted more variety and colors, which is why I added oak trees and cherry trees using the same technique. I also changed how the fog works. I'm back to the traditional depth to mix between the current color and the fog color, but with a little bonus. The fog color is composed of an on-screen radial gradient between two colors. I also added some scenery just to test stuff. Let's not forget that at the end, this portfolio needs to tell a story and provide activities to the player. I've added hexagonal basalt rocks. I've encountered those in real life and I find it amazing that nature can create this kind of shapes. I've added classic white rocks too, some furnitures, and pole lights that illuminate at night with little fireflies flying around. Those items don't have physics yet, but that's a job for future me. Finally, I removed the vehicle water controls I mentioned in a previous devlog. It was too difficult to navigate, car was getting stuck too often, and in the end, I can just let the car sink at the bottom of the lake. Now that the small features are out of the way, let's talk about the weather and its various demonstrations. I will go through all of them and explain how they are being managed at the very end. For the leaves, I finally got to use the compute. To put it in a nutshell, compute is a TSL implementation of GPGPU, which stands for General Purpose Graphic Processing Unit. The idea is that we use the GPU not to draw triangles and render pixels, but to calculate stuff. In this case, the transformations of the leaves. And yes, it works with WebGL and WebGPU thanks to TSL. The main benefit is that I can calculate complex animation for each leaf, but also that the position or whatever data is being preserved between each update. I created an instance mesh with a skewed plane for the geometry. I created a position and a velocity buffers that will be updated and preserved between each update. I created an init compute function to set the initial position. And an update compute function to update the position and the velocity. This update function is being computed on each frame. And in that update function, I started applying the various effects on those leaves. I pushed them with the vehicle. I pushed them with the wind too. I apply some damping. I make them fly up with their speed. I apply some gravity so that they fall down to the floor. I make them loop on the X and Z axes. And I add some rotation. And finally, I randomize the normal, the scale, the color, and there we go. Wind lines are just perfect for stylized world. They indicate the wind direction, animate the scene, but also create some kind of chill vibes without feeling too much of the scene. I started by creating points along a curve using the Three.js Cat-Mulrom Curve 3 class, and then created a geometry where the triangles are actually all together on the line. Using the vertex index and some math that I'm unable to explain anymore, I managed to move the vertices away from the middle of the line so that the faces are always toward the camera. It's probably the worst implementation of a fat line in Three.js, but I never said I'm good at math. I will probably get back to it at some point. Using some uniforms and attributes, I animated the thickness of the line so that they appear and disappear smoothly. Finally, I created a pool of wind lines, and at a random interval, I pick an available one from the pool and display it somewhere around the car. That one was probably the most anticipated weather hazard feature. To create a lightning, I reused the same fat line geometry as for the wind lines, but with much less subdivision. I also implemented a different animation where the arc appears immediately and then the vertices move away from the center in random directions. Let's make that lightning bloom already. I also added particles coming out from the floor to create an anticipation, and an explosion of particles coming out from the impact point. For those particles, I used a similar technique as the one I explained in the Three.js Journey fireworks lesson. I applied an impulse on the car if too close from the impact. I also applied an explosion on the leaves, which was surprisingly easy to implement. And finally, I created a camera shake animation, probably not great for the UX, but let's keep it for now. Those three features I mentioned, so the car impulse, leaves explosion and camera shake, are handled by the same explosion class, meaning that I can create explosion whenever I want. I just need to find something to blow up. Raindrops and snowflakes are the same thing in this case. The only difference is their weight. The snowflakes tend to fall slowly and move with the wind, while the raindrops tend to fall in a straight down fashion. I use the same approach as for the leaves with the compute position and velocity thing. I made them loop vertically so that they keep falling. I applied the wind with variations according to a Berlin noise texture. And I added a way to control the amount of visible drops. There is actually always the same amount of drops, but some of them are above the camera so that we can't see them. This way I don't have to update the buffers on each change, which is important to prevent performance issues. I already had nice ripples on the water, but I wanted more. First, I implemented ice that would show up on the shores. To do that, I first created a Voronoi texture using a render target on the first frame. The idea of the Voronoi is that we have a grid of points that we offset randomly, and we retrieve the distance of the pixels from the closest point. In this case, I save three different Voronoi information: the distance from the point, the distance from the edge, and a random ID. And I save each one in a respective channel of the texture: the red, the green, and the blue. Using that Voronoi texture and the water depth from the terrain texture, I displayed those nice little ice blocks. The second effect I wanted to add was raindrop splashes. To do that, I used the same Voronoi texture combined with the time to create animated radial gradients. I randomized the time using the cell ID and a Berlin noise. Using the edge distance and a step, I turned them into circles fading out on the edges. And I used the cell ID again to control the amount of visible splashes. That one was a big piece. If you follow me on X or Blue Sky, you probably saw the struggle. I wanted to have some thickness on that snow. so that we can see it piling up, but also to be able to see the wheel tracks. I couldn't use the terrain geometry because of the lack of subdivision, so I had to create a new plane geometry. The trick here was to make the snow plane follow the car on the X and Z axis, but while running up the value to the closest subdivision. By doing so, displaced vertices won't look weird and shaky because of the interpolation while moving around. I created an elevation node to retrieve the elevation for a specific coordinate. I'm using two different frequencies of the same Berlin noise texture to create randomness. And also the vehicle tracks I mentioned in a previous devlog, to which I added a big track at the vehicle position so that I can also move the snow down at the center of the vehicle. Using that elevation node, I moved the vertices up and down. So far, so good. When moving vertices like this, the normals are still pointing in the default direction, which is up in this case. To fix that, I use what I like to call the neighbors technique, where I calculate the elevation of the theoretical neighbors on X and Z directions. I then calculate the cross product of the vectors going from the vertex toward those theoretical neighbors, and that's the new normal. If you want to learn more about the neighbors technique to calculate normals, the Raging Sea shading lesson from Three.js Journey is perfect. And that's where things got a little bit more challenging. See those weird triangles in the shading? I needed to get rid of them. The most obvious solution was to add subdivision, but there goes the frame rate. After struggling for a while and even posting on X, I finally found a decent solution consisting on rotating the quad according to the elevation of the 4 vertices. I created a custom non-index geometry in which I also saved the pivot point of the vertices composing each quad, so that I can rotate the vertices around that pivot point. For each quad, I calculated the elevation of its 4 vertices. I then calculated the elevation difference between the vertices composing each diagonal. Finally, I rotated the quad according to which diagonal had the biggest difference. I don't know if it's the most suited solution, but it looks a lot better. And since I was using the elevation node method a total of 7 times per vertex, 1 for the elevation of the vertex, 2 for the neighbors, and 4 for the quad rotation, I moved everything to a render target that I render only once per frame. And then I pick the color from that render target texture, which should be a lot more performant, I hope. Finally, I added some glitters on the surface. Those fades in and out according to the camera position, but also slowly in time so that it's not too static when the camera is idle. All those weather features are great, but I needed a way to control them in a realistic manner with a level of randomness, yet kind of predictable. You don't want snow in the summer, but you expect snow during winter, especially at night when it's cold. I also wanted everyone to experience the same thing at the same time. In JavaScript, using this formula, you can retrieve a timestamp that is the same for everyone. I updated my day cycles class to use that timestamp and chose to make a day last 4 minutes. According to statistics on my old portfolio, people spend about 1 minute and 30 seconds on the average. I expect people to stay a bit longer on the new portfolio, and even if they don't spend 4 minutes on it, they should experience at least 1 dawn or 1 dusk and realize that the day goes by. I also created a year cycles class working the same way as the day cycles and used it to know how far we are in the year and tweak the weather according to the season. Next, I created a weather class containing 6 properties that can be accessed by every other component of the game: the temperature, the humidity, the electric field, clouds, wind, and rain. Each one has its own formula. Let's take the temperature as an example. I added a temperature to the day cycles keyframes so that it's warmer in the day and colder in the night. I did the same thing for the year cycle so that it's warmer in summer and colder in winter. And I also calculated a random variation through time according to a combination of 3 sine waves. Even with 3 sine waves, the curve is a little bit predictable. But it's not that noticeable, especially since some weather hazards will depend on multiple weather properties, adding up to the randomness. Also note that the weather is based on Eastern Europe seasons, well, because I live in France. I did the same for the 5 other properties and obviously added some monitoring and tweaks. The rain is the only property of the 6 that is based on the other ones. In this case, if there is high humidity and clouds, the value goes up. And finally, it was a matter of using those properties in the various components. For the leaves, the amount depends on the season with a high peak during fall, and they also move faster according to the wind strength. The wind lines always show up, but like for the leaves, they move faster with the wind strength. Lightnings will pop when it's cloudy, with a high humidity and high electric field. Note that the electric field is only high during the night because it looks cooler when it's dark, and I want the lightning to be a rare event. The amount of rain depends on the previously mentioned rain property, but in addition, the colder it is, the lighter the drops become, making them feel like snowflakes. Ice can be seen on the water surface when the temperature is below 0, and splashes show up when it's raining. And finally, snow piles up when the temperature is also below 0 and it's snowing. I then spent hours watching the weather in Accelerate and tweak those values again and again until happy. It's not a very realistic weather, and some of the approaches are quite abstract, like the electric field, but hey, I'm not making a Red Dead Redemption web version yet. And that's about it. I have some kind of special weather hazard I want to add, something a little bit more epic, but I need some time to think about it. Not gonna lie, I haven't tested the performance for a while. I really hope I can keep all those features, and I did my best to apply the most performant techniques, but I might have to get rid of the heaviest ones. Don't forget to follow me on X or Blue Sky for granular update. By the way, I received a new statue. Say hi to Reinhardt.